Imagine it's a typical Christmas day in 1895. You release 24 wild European rabbits out on your farm in Victoria, Australia, just to play rabbit hunting with friends. But for some random accidents, some of the rabbits eventually got lost in the wild. 7 years later, at least 13,987 rabbits were recorded in the same area. The number didn't stop there. It grew so fast and took over Australia more quickly than any other introduced species ever. Now, even when 2 centuries have passed, rabbits turned into the country's most costly pest animal ever, causing it to lose $206 million yearly because of their impact on the environment. Especially the beef, lamb and wool industry in Tasmania and Victoria, where the rabbit hunting happened at the beginning, alone lost $30 million every single year. That's the true story of how rabbits took over Australia, and this is Thomas Austin's farm in Bowen Park, Victoria, where the first rabbit escaped into the wild. Apart from the economic concern, this uncontrollable increasing number of rabbits also wreaks havoc on both agriculture and the environment in several ways. One of which is destroying over 297 crops and plant communities, including 24 critically endangered species because of rabbit overgrazing. Rabbits eat almost all types of plants and vegetation, from ringbark trees to shrubs. They even eat seeds that plants need to regenerate, leading to soil erosion. It's a vicious cycle, especially during droughts and post-fire periods when food becomes scarce. They will eat whatever they can just to survive. Moreover, rabbits graze closer to the ground than domestic livestock and feed on newly planted vegetation. This weakens perennial grasses and paves the way for invasive weeds to take over. Hence, not only livestock production, but also revegetation projects and horticultural operations are negatively impacted. Research in semi-arid sites has shown that even one rabbit running wild per 2 hectares can severely threaten some plant species. When too many highly prolific rabbits are in one area, they compete with other animals for food and shelter, leading to biodiversity loss. Several small ground-dwelling mammals, and even seabirds, facing extinction due to rabbit interference. Not only that, the abundance of rabbits also sustains high numbers of native predators like cats and foxes, putting additional pressure on the control program. For example, the foxes may suffer from food shortages when rabbit numbers crash after control. But how could seemingly small and harmless rabbits change the entire ecosystem so quickly? 2 main reasons. First, they have high production rates. These prolific breeders can produce a significant number of offspring in a short amount of time. According to Agriculture Victoria, a pair of rabbits can turn into over 180 rabbits in just 18 months. Their breeding is most active during the wetter months, which makes Australia an ideal place for a rabbit population explosion. Second, rabbits also have high dispersal rates, which means they move from one place to another pretty fast. In 1880, there was a record of them crossing the Murray River into New South Wales, then reached Queensland in 1886 and Western Australia in 1894. That's more than 5.500 km in total. So how do Australian farmers and governments tackle this invasive rabbit overpopulation problem? Early attempts to control rabbit populations relied on mechanical barriers like rabbit-proof fences stretching over 1,700 kilometers, together with the additional release of rabbits' natural predators such as European red foxes and feral cats. Bounty hunting, shooting, and trapping were also employed to reduce rabbit numbers, but their effectiveness was limited on a continental scale. These measures aimed to curb rabbit dispersal. However, despite these efforts, the rabbits continued to multiply, reaching an estimated 496 million at their peak in 1880. In the 50s, Australia turned to biological warfare against the rabbit invasion. Myxoma virus, which causes myxomatosis, a type of viral disease that only kills rabbits and hares, was put into use in 1950. The virus decimated over 90% of feral rabbit populations initially. However, the rabbits developed resistance over time, reducing the virus's effectiveness. A few years later, myxoma virus can only work approximately 40 to 50% of the rabbit population, which is a low number. Therefore, Australia has stopped using it to control wild rabbits. In 1996, a breakthrough occurred with the introduction of rabbit hemorrhagic disease virus 1, or RHDV1. This Czech Republic's highly contagious virus strain caused widespread death among rabbit populations. Just like the myxoma virus, RHDV1 knocked down 90% of the invasive rabbit population, but then quickly became resisted. Researchers had to prompt the search for a more potent variant. They found a new variant of this same virus, K5, sourced from Korea. It can overcome genetic resistance in rabbits. This virus showed promising results, although its effectiveness varied from region to region because it just stayed at the original release site and didn't spread. This has paved the way for RHDV2, first released in 2017. In contrast to K5 and the Czech strain, it can kill 3 to 4 weeks-old rabbits and vaccinated adults. Nowadays, this virus is the dominant RHDV strain used to control pest rabbits in Australia. But viral resistance is still a big risk for the control of rabbits. Scientists went on a search for other multifaceted approaches, including chemical interventions in this battle against rabbits. A series of chemical control methods called rabbit recipe have proven highly effective in reducing rabbit populations. This mixed method is now also recommended in Agriculture Victoria's Integrated Rabbit Control Guide. The rabbit recipe includes baiting, ripping or harbour removal, and follow-up fumigation. The main goal of this method is to destroy the rabbit's habitat. Rabbits rely heavily on burrows and warrens for shelter and protection. When their habitats are disrupted, their survival rates plummet. Let's break the rabbit recipe down stage by stage. First, baiting. There are 2 main toxins used for baiting in Victoria, 1080 and Pindoni. 1080 is a compound derived from native plants. It is highly effective against rabbits, but requires careful management due to its toxicity to other animals such as domestic dogs, cats, and livestock. When 1080 is either impractical or unsuitable, farmers can use Pindoni, which is an anticoagulant poison. When swallowed, it will disrupt the blood clotting process, making rabbits die slowly from anemia or hypovolemic shock. Because of this delayed death, poisoning with Pindoni can easily be successful because the bait overcomes shyness that may have occurred with strong, acute toxins. Farmers often use pre-mixed baits such as carrots or oats laced with these toxins, strategically placed to attract rabbits, like the trail baiting method. Second, ripping. Farmers will destroy rabbit warrens to make it harder for them to reproduce and survive. If this step isn't done, the whole rabbit control program will fail because new rabbits can still take shelter in those already dug warrens. Finally, fumigation is used to eradicate rabbits within their warrens. For this step, toxins and poisons like carbon monoxide are often used to effectively target rabbits within their underground home. But this only works well with moist soil and high terraces, plus the warren has to be completely sealed as well. The rabbit population in Australia looks promising as researchers continue to refine existing methods and explore innovative solutions, such as the introduction of additional pathogens. However, it's essential to remember that alongside these efforts, the humane treatment of all animals, even pests like rabbits, must remain a top priority. As we move forward, striking a balance between effective population management and ethical treatment will be crucial in ensuring a sustainable and humane approach to rabbit control in Australia.